Hello folks, we are now with the new video of our chapter 2, our class 12. We are starting the videos now, and this is our chapter 1, relations and functions. We'll be starting with the exercise 1.1, and this is our part 1 video. Now, relations and functions is nothing new to us because we've done that in the 11th standard. Again, the same heading, relations and functions. So we had learned what is relation and what is a function. So in the upcoming exercise, we'll be only building up on what we have learned earlier. So like for example, we had learned what is we had understood what's a relation. Like first we defined a set. We first defined a set A or whatever with whatever the thing that's given to us. Suppose A is a set like 1, 2, 3. Then suppose you have a set B which is made up of elements A and B. Then first we had the Cartesian product which were ordered pairs. So this was a Cartesian product. So this is the biggest connection. Now from here, whenever you take a subset of this, that is what is called as a relation. Take any subset. For example, suppose if I take a subset R1 such that R1 is equal to maybe 1A and 3B, suppose, then this can be called as a relation. So a relation basically is a subset of the Cartesian product. So on the basis of that, we are going to elaborate on that and we are going to learn more things. So that's what our scope is all about. So this is what we learned last year, and this year having got a relation, there are 3 types of relation, that is called as transitive relation, symmetric relation and reflexive relation. A relation is reflexive if all the AA's belong to R. Any element that is there from where the collection is starting, every such element AA should belong to R, then it's reflexive. And a relation is symmetric when for some AB that is belonging to R, if BA also belongs to R, then it is reflexive. Then transitive is, suppose say you have 2 elements AB and BC that is belonging to this relation. You see the commonness. Yeah, if that is the case, if you have an AB and BC belonging to R, if it implies that AC belongs to R, then it is a transitive relation. So all this we have to show in the upcoming questions, that whether the given relations are reflexive, symmetric or transitive. So we're going to see how we can do it. How, first of all, we have to define a relation. From the given set we have to define the relation, find that set R, and from the set R we have to see what the whether it is going to be reflexive, symmetric or transitive. That's what we're going to do. Right, now let's check here. X is 1. If X is 1, every time we have to take Y. So Y is 3X actually, and we do the shifting. Suppose X is 1, then what is Y? Y is 3 into 1, 3. If X is 2, what is Y? 3 into 2, 6. If X is 3, what is Y? Y is 3 into 3, 9. See, from till here it's okay. The things are going on okay, but here there's a problem. This we cannot accept. Why? Because this Y and X, they have to be in A. It's been defined in the question that both these elements X and Y, they have to be in the set A, and set A has got elements only till 14. So this element 15 is not there in the set, so we cannot accept this. So actually your set R is consisting of what all elements? It will have 1, 3, it will have 2, 6, it will have 3, 9, and it will have 4, 12. These are the elements that's there in the set R. Now, from this, you have to find out whether it is reflexive, symmetric and transitive. So it's very clear to us it's not reflexive, because you cannot see these repeated elements. When it is there, then only it becomes reflexive. 1, 1, 2, 2, 3, 3, 4, 4. You should be, because it is defined on this set A, you should, if at all it's reflexive, you should have 1, 1, you should have 2, 2, you should have 3, 3, till 14, 14. All elements should be there, then only it become reflexive. Even if one element is missing, it's not reflexive. So that's not happening. So it's not reflexive. So we will highlight that reflexive. 1, 1 doesn't belong to R. Not necessarily 1 comma 1, anything till 14, but for simplicity we are taking 1 comma. It's not reflexive. Then symmetric. Symmetric means you take any element like 1 3, suppose here 1 3 belongs to R, but 3 1 doesn't belong to R. Just check. 1 3 is belonging, but 3 1, it's like mirror image, it's not belonging. And if that is the case, therefore R is not symmetric. Okay, then transitive. So transitive, and I had told you the condition. So for this we have this 1 3 and 3 9. Those are the only two elements with commonness. So we observe that 1 comma 3 3 comma 9 belongs to R, but 1 9, that's how we take it. 1 comma 9 doesn't belong to R, right? And that is a condition for transitivity. The common element you skip and you take the extreme elements, and that should be there in the set, then it becomes transitive. Therefore R is not transitive. So none of the thing is happening here, right? It is not symmetric, it's not reflexive, it's not transitive. Okay, this is how we go across showing this. So the whole exercise more or less is like this, and by chance sometimes they ask us to show counter example also, so we will give the counter example whenever it is required. Okay, now we have this R equal to this. So same story. First let's get the R, and then see, they have said that R is a natural number. In R you are taking natural numbers, but the x is less than 4. They have not told anything about y, but they have said that x is less than 4. So what all values can x take? If it's a natural number, x can take 1, x can take 2, and x can take only 3 because it's strictly less than 4. 4 is not included. So if x is 1, what's the y value? 1 plus 5, 6. Then what is the y value? It is 2 plus 5, 7. What's the y value? It is 2 plus 3. Wait, 1. This is 1 plus 2 plus 5. Yeah, 2 plus 5, 7. And this is 2 plus. And this is 3 plus 5, 8. Yeah, 6, 7 and 8. Yeah, so what's the relation? The set R is 1 comma 6, 2 comma 7 and 3 comma 8. It's clear, it's not reflexive, symmetric and transitive, it's not there. So we can have this reflexive. Since 1 comma 1 doesn't belong to R, so R is not reflexive, as easy as that. Okay, so it's not only 1 comma 1, all other elements 2 comma 2, 3 comma 3, they are all not there, but then to start at least one element is not there means that's enough for us to tell that does not belong. That's it. Then we'll move to the symmetric. So any element, if you take 1 6 6 1 is not there. Now 1 6 belongs to R, but 6 1 doesn't belong to R. So R is not symmetric. Right? Then transitive. Transitive we cannot check here because there we had this coinciding element over here, but here there is no coinciding element, right? So it's better we say that we are not able to check it, because unless there is a coinciding element, how do we say it's not Of course it's not, but then how do we say it? Because we're not able to check it, we don't have the raw materials for it, so we'll say cannot be checked. Okay, this condition cannot be checked. That's it. So that's about our part 1 video. Of course, we have some voluminous exercise with 16 problems, and question 1 itself, this problem itself has got 4 subparts. So 2 more subpart is left, and then you have those voluminous questions are voluminous where you have to do lots of writing, and certain examiners, they demand too much of writing, so then in that case you have to fulfill them. So we'll write it, we'll learn writing, and when need be we'll use it. So that's how we're going to go about it. Now to start with, we will be finishing this video, taking the next video, that will be also a small one, until we get into the wavelength. Then we can take little bit voluminous videos. Thank you.